Hello, welcome to the course Build Dynamic Simulation Model of an Electric Vehicle with MatLab software. So let's have a look at the content of the course. There are total 9 sections. It starts with introduction, then derive mathematical model of vehicle. After that we will develop the simulation model of the vehicle. Then we will understand the simulation model of specific vehicle. Then simulation model of electric motor, and then we will see how to connect electric motor with the vehicle motor model that we have developed. Then we will see how to connect the electric motor model with the vehicle model that we have developed. Then we will discuss about the one specific vehicle model, 20 kg vehicle model, that is powered by 5 HP electric motor. And in section 8 we will analyze different vehicle model and final summary. So let's have a more in-depth look. In the introduction section we will just getting started and see how the course flow and different requirement. In the section 2, derive mathematical model of the vehicle, we will derive the mathematical model of the vehicle. We will see the mathematical equation. And in section 3 we will develop dynamic model of the vehicle with the help of MATLAB software, and then we will analyze it and we will learn how to extract the speed torque characteristic of the vehicle by performing the experiment on the simulation model. Then we will see how to store this characteristic in the lookup table for the further use. Then in section 4 we will develop simulation model of the one specific vehicle car model, that is Maruti Swift Dzire. Then you will have the homework. You will develop the simulation model of one specific car, and you will have to develop the simulation model of one specific bike. Then in section 5 we will derive mathematical model of DC motor. Then we will develop the simulation model of the same DC motor in the MATLAB, and then we will derive the constant Kt and Kb of the DC motor which is required to calculate the rated current and rated torque of the specific motor. So you will understand these all things in this section. Then I will share the DC motor specification from the 5 HP to 75 HP, so that can be used to develop the any electric motor model in the MATLAB Simulink environment. So after that we will see how to connect the electric motor model with the vehicle model. We will first understand the problem in connecting the vehicle model to the electric motor model. Then we will have the solution, how passive loading scheme can be used to connect the vehicle model with the motor model, and then we will see how to validate this scheme. Then summary of the passive loading scheme. So then homework for you, you will connect your vehicle model that you previously developed with the 70 HP DC motor. In the next section we will analyze the performance of 20 kg vehicle model, and we will observe it when it is powered by the 5 HP electric motor. Then we will see how to build the motor model and use the inbuilt model of the motor that is available with the SimPower System library, and how to specify the parameters in this motor model, and we will compare the previously we designed the motor model with the SimPower System library and what are the benefit of the SimPower System library. So those who are working in the power electronic electric drive, they want to use the motor model from the SimPower System library to validate the converter and the control strategy. Then we will see the current limit and speed control requirement of the DC motor. And now your homework, you will add the current limiter and control to the model of vehicle that you developed previously. So this way slowly we are getting close to the final vehicle model. And in the section 8 we will have the different vehicle model, analysis of different vehicle model. So it will help you to understand how to analyze the vehicle model and how to extract the performance from the model we have developed. So first we will look at the 20 kg vehicle powered by the 3 kilowatt 48 volt DC series motor. Then we will observe the performance of Maruti Swift Desire powered by the 50 HP and 240 volt DC shunt motor, and at last Maruti Swift Desire powered by the 60 kilowatt switch reluctance motor. So this way, by this scheme, we can have the two separate model of the motor and vehicle, and we can connect it together to predict the performance of the complete vehicle system. Then we will summarize the classification of electric vehicle simulation, so one can further extend the study. So the students from any branch of engineering, including diploma studies, can learn how to build the simulation model of an electric vehicle system. However, a basic knowledge of the MATLAB simulation software is required. So let's join the course, learn the simulation and share your result.